I'm going to talk about load testing in continuous integration process. Probably some of you may know the principle of continuous integration, and others may not know not much about it. So the idea of continuous integration is that you want to automate with a continuous integration server to automate the build of your applications and also the tests on your application. So it may be some tests about the quality of code or things like that. And it can be also some unit tests. And here, the idea is to put some load testing, some performance testing also for your application that you are building and testing. So the thing here in the summary of the subject is that when you want to test a distributed application, then you have to, in your continuous integration process, you have to build the application components and then to deploy these components, to instantiate them, to configure them, and also to do the same thing with the load injection system. So it's kind of magic today to think about it. But let's see together how we can reach this magic. I'm Bruno Dillenseger from Orange Labs, and this work has been mainly carried out with my coworker Xavier Etchevers, who could not come today. I would say that also that this work is still under development. It's not the paint is not dry yet. Okay, so what is CLIF? Just a reminder about what is the CLIF, the load injection framework. So we can say that it's in the OW2 consortium, the load testing software. Its peculiarities are listed here. So first, it is generic and extensible, which means that we can support a variety of IP-based protocols to generate traffic, including voice over IP, HTTP, of course. We can also generate traffic on a database, on mobile networks, and you can also integrate your own custom protocols. So the idea of load testing is that you have a number of load injection machines here. You generate a traffic on a system under test, whatever it is. It can be some networking, some storage, some servers, your web application, for example. And typically, the tester has a console to define and execute, control, supervise, and analyze the results of the test. CLIF is flexible. You can find it in a number of integrations. The main integration is in the Eclipse integrated development environment. You can find it also as a standalone Java application. You have also a full-fledged command line interface. You have also a Maven integration, and also, which will be of great interest for my speech today, an integration to Jenkins, the continuous integration server. I would say that CLIF is advanced also in that we can easily, with CLIF, have millions of virtual users emulated in a single load injector. It's not magic here, it's just the thing that if your virtual users require little resources, then you can have lots of them. We have also experimented test plans with more than 1,000 distributed load injectors. And CLIF is a continuous research transfer asset. For example, at the beginning, CLIF is a transfer of research work in component-based software engineering. We have been also transferring some results in the field of autonomic computing with self-regulated load injection and self-driven test campaigns. Also self-optimization of servers. And well, today we are, of course, working on transferring research results about cloud testing. And I would say also finally that it's a mature project because it's 11 years old this year. So now I have presented CLIF. Now let's have a look at Jenkins. The idea in this talk is that we are going to do some load tests in continuous integration, and we are starting from the Jenkins continuous integration server. As I said in introduction, the idea is to automate the test and also to automate the reporting, the analysis of the results of the test and the reporting. So with Jenkins, you get a per test report as well as a report with the trends through the successive tests in order to see that if your metrics are improving or not. So with the Jenkins, Jenkins is extensible with a plugin. So we have integrated CLIF as a plugin in Jenkins, which naturally brings load testing and performance monitoring capabilities to Jenkins. Okay. So now this is fine. We have load testing from Jenkins, but there are a number of questions that are still here. First of all, imagine that your system under test is a distributed application. How? Well, you can run the build process, which is usual, based on Maven, for example. But after, you have to deploy your application components. You have to configure them, and including all the IP addresses resolution, since you have a distributed application. So you have to resolve the client-server dependencies, which you cannot know in advance. Okay, and it's quite the same problem on the load injection part. You may have several load injectors to have sufficient load injection capabilities, and well, you will have to deploy and configure those load injectors. And I would say also interesting thing is that your load testing scenario, the thing that will generate the request, must know also the IP address of the system under test. And you have to resolve this also. And finally, the question is, well, on which infrastructure? Do I have to operate my own metal-based infrastructure, virtualized infrastructure? Do I have to make my own data center and to operate it to do that? So now let's have a look at this new element, which is VAMP. The Virtual Appliance Management Platform. VAMP intends to deploy virtualized distributed applications over the cloud. So virtual appliance is a virtual application, distributed application. Its peculiarities is that it works with pluggable IaaS drivers, including OpenStack. So it can operate on a variety of infrastructure, underlying infrastructure. We can also have multi-IaaS support if we use the Sirocco driver. Sirocco was briefly presented this morning. So it's a kind of broker or a multi-IaaS layer. VAMP will also integrate some generating and publishing virtual image machines images using the UForge technology that was presented by UShareSoft this morning. Okay. VAMP is based on a component-based description of the application's architecture. We'll see later how in more details. And it is also designed to provide advanced and autonomic management features like self-repair or elasticity. Well, elasticity is still work under progress. So what are the life cycle steps of deployment with VAMP? Well, first of all, you provide all the applicative elements, including the binaries, the packages, data, and so on. VAMP will generate the virtual appliance. It means it will generate all the virtual machine images. Then these images will be published in the target IaaS infrastructure. So this is, these are steps in the life cycle. It is not, but it is not achieved by VAMP itself. It's if you want actually to do this, you have to use the UForge technology. Once images are published, you can VAMP will instantiate the virtual machines, and afterwards they will be configured. There are a number of sub lifecycle steps here, but they are not mentioned for simplicity. And once they are configured, the application is started, it's activated. Basically, the description of virtual appliance, or distributed virtualized application with VAMP is based on OVF, and it's an extended OVF, the Open Virtualization Format, that adds a number of elements. These are architectural elements. Well, first of all, you have here the virtual machines. So in this OVF description, you will have the list of all virtual machines with their CPU, memory, networking capabilities, the disk, and so on. This virtual machine will be associated to virtual machine images with the format of the image, the operating system, the packages. So here you may have a full description of your software stack that you want to deploy for this particular virtual machine. Then you have the applicative component. We'll see what is an applicative component in more details afterwards. The applicative component will run on a virtual machine, okay? It will have a number of interfaces, either server interfaces or client interfaces, in order to represent the client-server dependencies. It may have also a number of attributes for its configuration. And then the architectural description of the application will exhibit the bindings, which are the links between the different interfaces, so client interfaces with server interfaces, okay, which is the client-server dependency artifact. So typically the IP address resolution thing will be based on these bindings definitions. Now, yes, in the background image, there is a piece of OVF description, which is very, very verbose, based on XML. We have developed a graphical modeler, a GUI for these OVF files. So here you see there are three virtual machines. The application is a classical web application with a load balancer here with Apache. And then you have an application server and then the MySQL database. Okay, so we have three virtual machines and we have 5 components. The first one is the Apache load balancer component. Then there is the Jonas application server, and you have also the RAR and the EAR files that will be deployed on this application server. Here, it's not really easy to see, but you have some bindings between here the server interfaces and the client interfaces. So you see the one between the load balancer and the application server, of course, and there are also bindings between the RAR, the EAR, and the application server, and there is also the binding with the database here. Now, if we go back to the load testing issues in continuous integration, then now we have 3 supporting tools. We have Jenkins and CLIF, of course. And now we have also VAMP that will answer our questions about the deployment of the application under test and of the load injection system. So what we have to give in input to this system is to give, of course, the application under test, the build chain, like as usual in a continuous integration. And then we also have to provide a description of the an OVF description of the architecture of this overall application. So now we'll consider that the application to deploy is the composition of the system under test and of the load injectors. And we also have to provide the CLIF test scenario in terms of, for example, virtual users that will perform requests, think times, and the very usual things about load testing. So now this is the same application, web application here, exactly the same, but we have added 2 load injectors, and we have bound them to this interface. This interface, whose name is local IP info, will handle the resolution of IP addresses, and the result is that the load injection scenarios that will be deployed in nodes CLIF 1 and CLIF 2 in those virtual machines will have the IP address of the Apache load balancer once the deployment is achieved. So let's summarize the overall process. You have the tester here. He or she defines the CLIF scenario, of course, as usual, and also it defines also the OVF description of the application and load injectors. This is pushed to the continuous integration server, either directly or through some SVN or Git repository. And then the continuous integration server will trigger a test by asking VAMP to deploy this description. Okay, with here, in our case, the 3-tiered application and the 2 load injectors. And VAMP will instantiate the virtual machines and components, will configure them and start the application. Optionally, you have those 2 boxes here. So if you want to be able to deploy on multiple IaaS in this test, we'll have to use the Sirocco web service. And if you want to enable the virtual image generation and publication to the IaaS, you will have to include, it's just a matter of configuration of VAMP, to include the uForge utility. Okay, now we are going for a demonstration of this. So the first step is from the tester point of view. As a tester, I use the usual classical CLIF console, which is based on Eclipse. Sorry, it's a little tiny. So yes, some of you may have recognized the Eclipse environment. And this Eclipse environment is enabled with the CLIF plugins here, we see. Okay, in this CLIF console, as usual with Eclipse, when you want to define a test, you create a new project. It's a CLIF test project. And inside, you will gather your scenarios. So in this case, I have, as a starting point, I'm the tester, so the development team has provided me with the architecture of the application to test. It's here in the springo.ovf file. And then what I have to do as a tester is to define the same architecture, but adding some load injectors to it. And what I have to do also is to define the load test scenario. So just have a look at this. you will see that the scenario is just something like, here we are testing a web application, so it's a sequence of HTTP GET methods with the URI here. Okay. And with the think times. We see also here the load profile, which is the number of active virtual users running this behavior according to the test time. Okay, so okay with it, with this. And now what the tester has to do is to edit and to create the CLIF with the application architecture. So we are using a modeler here. Here is the modeler. So I choose the application architecture definition. Here it is. Okay, so this is provided by the development team, and as a tester, I just have to add the load injectors. They are available here. So first of all, I have to put a CLIF node. And in this CLIF node, I can drag and drop a load injector. Okay. And here, I have to specify the scenario that will be run by the CLIF injector. So I click on it. Comment. Injector 1. Arguments. Argument is the name of the scenario that I've shown you. Springo.xes. It's not a probe, so nothing to put. It's an injector designed with the Isaac environment. Okay, that's almost it. And I can put also another load injector. Okay, and do the same with the same parameters. And also, what I have to do now is to tell my load injection system where I will inject load. CLIF is multi-protocol, so I could inject load on MySQL directly. I could generate load on the application server. So all of this is done by this little client interface that I have to bind. Here, I want to generate HTTP traffic, so it's on the Apache load balancer. Okay. And when I'm done, I save, and this is the content of the file. Okay, big XML file. Here I did not give the full description of the software stack because I will start from a predefined, pre-published virtual machine image. Okay, that was it for this. So once this is done, I save, and this is the result, the CLIF plus springo.ovf file. Okay. This actually is published to an SVN repository that we can see here. Okay. Oh, this is synchronized with it. I cannot do it live because I don't have the connectivity to this server, but I have prepared some things before. So if I now jump to the Jenkins integration server, we'll see the configuration of my Springo job. Okay, so we are in Jenkins. We define the load test job. The name is Springu, and if I go a little bit further, okay, so we see that all the resources, the files will be downloaded from an SVN repository here. So it will be exactly the content of my Eclipse project. And then here we see that there is a CLIF task defined with a specific CLIF environment. And here we have the name of the OVF file. We specify that we want to deploy this OVF file. And here we specify the endpoint to the VAMP manager web service. And the last line here is just the name of the identification of the virtual machine image in the IAS. Finally, I have, after the test, I have also the post-build action, which is the CLIF performance report, publishing with a number of parameters. Okay. And then when I'm ready, I just have to click on Build Now. And now I'm going to switch to video. Okay, let's go. Okay, so this is the job name. Now there is the URI to the SVN repository, the CLIF task, the parameters, now you can run the test manually. The job has started. You see the new job here. And we have a look at the console output in order to see the execution traces. We see here that all the files of my project have been downloaded into the continuous integration server. And now here we see that we are waiting for VAMP to deploy our CLIF plus Springu.ovf description. Now we have a look at the OpenStack dashboard, because in this example, VAMP uses the an OpenStack infrastructure to deploy. First of all, you see that VAMP will instantiate a deployment manager virtual machine. This virtual machine will be dedicated to the management of the deployment of the application. Now we have to wait a little bit. We accelerated time so that it doesn't last too long. And that's it. We see all the virtual machines created. The load balancer, MySQL, and machine 1, 2, 3 are my load injectors. And here's the application server virtual machine, and at the bottom, the the deployment manager. Okay, so now the CLIF load test is about to start because all the virtual machines have been created. But we still have to wait for all the components to be ready, to be up. So let's switch to the last video, which is not really nice, but I don't know why. There's a kind of zoom, which is ugly. So this video says that the load test has started, and then everything has been deployed and started. And then the job is waiting for the end of the test. And when the test is complete, then all the measurements are gathered from all the load injection nodes. And then, yes, then all the virtual machines that have been created are destroyed using still the VAMP web service in order to clean up the environment. And finally, a test report is automatically generated. So the test report now is ready. And we have a look, sorry, it's in French. We have a look at the performance report that has been generated automatically. So here we see that all load injectors have been aggregated in order to get the statistics, the global statistics about the request. We have also a number of graphs automatically generated, response times, also moving statistics about response time and throughput. We have also a distribution analysis of response times. And we also have these trends for each kind of request, which are very, very interesting. I mean, it's one of the strong ideas behind the continuous integration to have the evolution of the quality of the software. And that's it. Okay, it's time for conclusion. So you have seen a demonstration of load testing in continuous integration deployed over a cloud. Here are the references of the elements. So this demonstration was just based on Jenkins, VAMP on CLIF. And optionally, you have also Sirocco and UForge, and you have the references. This work has been developed in the context of the Open Cloudware platform as a service project that has been presented this morning. So it's the end, and I wait for your questions.